Hello, everyone. So welcome to today's training. And I'm here today to talk about the intermediate Linux. And today we'll run a few Linux commands on expense, but generally is applicable to other HPC systems. You will find similar Linux systems on many other HPC clusters. Here is the complex slice. Today's training session is a part of Complex, and Complex is supported by NSF. And here is today's outline. We will first have a brief introduction about today's training, and then we will go to different topics. Those topics are the symbolic links, redirection and pipes, wildcard and globbing, alias, command history, navigating between directories with pushd and popd, environment variables, configuration files, sudo, file systems, Linux cores, and file permissions. Today's training session is for anyone who works in a Linux environment and wants to acquire additional skills to more effectively use advanced cyber infrastructure, CI. In the Linux world, intermediate is in the eye of the beholder. Everything that we are covering in this session would be considered basic or elementary by Linux system admins. But if you are attending this session, you're probably not a sysadmin. Rather, it's more likely you are a student, educator, or researcher who uses advanced CI as part of your work or studies, in which case, these topics really are intermediate in the context of Linux users instead of Linux professionals. And please know that shell scripting is put in a separate session. We're doing this because that we can then focus more deeply on the intermediate Linux topics. And we assume that you are already knowing the Linux basics, such as you know how to run ls commands, the remove commands, and how to cd to different directories with cd commands, and you know how to list file contents with the cat, head, tail, less, more command. And you also know how to use the text editors such as the Vim, Nano, Emacs to open or edit your files in the Linux systems. And you also know the relative and absolute paths. Now let's go to the first topic of today's training, which is about the symbolic links. Symbolic links, also known as the soft links, give you a way to refer to a file by a different name. They are very useful when you want to avoid writing out a full or relative path name every time you change to that place, or if you want to have a generic executable name refer to a specific version. To create a symbolic link, use the ln command with the dash option. Because if you don't add the dash s option, you will end up creating a hard link by default. Now, in the next few slides, we will explore some of the useful properties of symbolic links and how they are used in the real life. So the symbolic links can be created even if the file being linked to does not yet exist. In the example below, we only have one file called file1 in the current directory. We can, of course, create a symbolic links to that file1, the symbolic link is called file1-soft. And we can also call another symbolic link to the file2 that doesn't exist. The ln command can still run, and if we list the content of file1 with the cat command, we can see that we get the contents of the file1. But if we list the contents of the file2-soft, we will not get any contents because file2 does not exist. But once we create the file2, we list the file2-soft again, then we can get the contents of the file2. If we remove the symbolic link, the original file will not be affected. So in this example, we removed the file1-soft and file2-soft, and then we will find that the file1 and the file2 are still existing in the current directory. And a file can have multiple symbolic links. In this example, we are creating 3 soft links to the file1. It's file1 soft1, file1 soft2, and file1 soft3, and they can both exist in the same directory, or you can put them into a different directory. Symbolic links can point to directories or files in other directories using absolute or relative paths. They can even span file systems. And in this example, we are inside the home directory, and then we create a symbolic link called file4-soft, which links to file4 in the lasher scratch directory, and that's absolutely fine. And then we can check the contents of file4 with the file4-soft directly in our home directory. So how do I know if a file is a symbolic link? We have a few different ways to check whether a file is a symbolic link. The first method is we run ls dash uppercase F. Then those links will have a at append to the file name. And more often, we can just run the ls -l commands. And so in the long listing format of the ls output, you will see the L in the first column of the output and the list the file it points to. So in the below example, we can find the file1-soft and file2-soft. Those two are symbolic links, and in the long listing format, the first column is L, and then you will find they are links to file1 and file2 respectively. And also, if your SSH client or your terminal supports the color display, which is ls-color equals to auto, then you will find that those symbolic links are showing in teal. Teal is a color name. It's close to cyan or green blue. So that special color. Through that special color, you will know that that file is a symbolic link. And here are some symbolic links use scenarios. First, you may have an application that has multiple versions. Although we can occasionally access the earlier versions, we normally want to use the latest release. By creating a symbolic link to this most recent version, we can avoid having to update our job scripts or workflows by just updating the link. Or if we have multiple input files, and while one of these files is different for each calculation, others refer to reference data that really changes. We can then create a symbolic links that point to the latest reference file. And also when you cd to a directory with a very long path name, we can avoid writing out a full or relative path name every time if we create a symbolic link to that path. So here are the examples of those three scenarios. And in the first gray blocks, you can see that we have a executable called CFD app, and we have a few different versions of that app in our in our directory. And if we create a symbolic link to the latest version of that CFD app, then next, in our JavaScript or workflow, we can always use that CFD app.exe, which is actually a symbolic link to refer to our application. And that's same for our input data file called ref.date. We can also create a link for that data. And in the last gray box is the example of creating a symbolic link for a long path. And the in my home directory, I can create that link to some place in my scratch space. So every time I log in, I can just cd to that link so then I will go to my scratch to that particular place in my scratch. Okay, any questions about the symbolic links? Uh, if no, then we will move to the next part, which is about the redirection and pipes. Most Linux commands write to the standard output, which is the terminal you're working on the command line, and the output can be redirected to a file using the greater than symbol. Or if you want to append those output to a file, you can use the double greater than symbol. So every time you run that command, the output of the commands will be appended to the file. So next, a pipe will take a standout from one command and direct it to the standard input of a second command. Arbitrary number of commands can be connected using the pipes. Like in this example, we are listing the current directory in a uh, long listing format, and we want to count how many lines of the ls command output. Then we can use the pipe to takes the standard out of the LS and then to the WC command, and then we get how many lines of the output of LS have. Or you can use multiple pipes to work for the different commands. And in the next example, we can list the 3 longest running jobs on expense node, and we can first run the SQ command and get its output, and use the pipe to get the result to as the input of the grep, and then we can get the output of the grep uh, to the head command. Use the second pipe. So that in that way we can get the 3 longest running jobs on that expense node. And standard in can also be redirected. This is sometimes useful if you want to prevent a command from listing the name of the input file. So in this example, if we just run word count -l file1.txt, we will find that the output includes the file name. If we want to remove that file name, we can use the pipe to get the output to as the input of the card command. But we can also use the we can also use we can also use the less than sign to redirect the standard input uh, of the file1.txt to the WC command, and in that way you see the command is shorter and simpler, still can print the result we want. And next we will learn more about the wildcard and the globbing. So wildcards let you express a pattern for matching multiple file names using any combination of the following. The question mark matches any single character, and the asterisk matches any string, including the empty string, and the curly brackets matches multiple characters or range of characters. And what is a globbing? Globbing is the operation that expands the pattern into a list of files. Globbing is done automatically by many Linux utilities that operate on files such as the ls, rm, move cat head, tail. And in the next example, we will see how the wildcard and globbing using the asterisk works. In the current directory, we have a few text file and exe files. If we want to find all file names beginning with the file, we can run ls file asterisk, and then the command output will give us all file names beginning with the file. If we want to find all file names beginning with F, then we can just run the ls F asterisk, and of course we can put the asterisk before or after any characters we want. And in the last example, we can see that we are listing all file names containing the GHI. And same for the wildcard and the globbing using the question mark. But the question mark only only refers to the single character. So in the examples here, we the first uh, example shows the file plus any single character plus the dot date extension. If we run if we run first example, which is ls file question mark dot date, it will list any files begins with file and then plus any character plus plus the dot date extension. And of course, we can use the question mark and asterisk in the same command to search files as we need. And the in the last example, we can use multiple question marks together in the same command line. So you will see you will see that we are listing any 5 characters plus the dot plus any character single character plus X, and then the file ends with any single character. So it will give you the result here, and you can also use the curly brackets in the wildcard and globbing search, like those examples list here. The first example lists multiple matches using the list of integers, which are 1 and 3, and or if you want to. So with the curly brackets, you can include a certain part of the numbers or letters to search, or a range of those numbers or letters to search. And here are the example. Here are those examples are showing how to use the curly brackets here. So why we are using the wildcards and the globbing with the question mark, asterisk, or the curly brackets? This is because sometimes those file names are really complicated because of the application, maybe because of the workflow or applications you're using. Those applications may have every information saved into the file name, such as the date and which batch or which input and output to have one running those workflows. So you will get a very long file name, and usually you will have files in the same directory. So if you want to access a few of them, you will then need to use the wildcards and the globally to get the particular files you need. Okay, next is about the alias. Alias are just shortcuts for the Linux commands. They are useful for keeping you out of trouble. For example, if you don't want to accidentally deleting all files with the remove command, you can set a alias that can ask every time you're trying to delete files. And the alias can also abbreviate in complex commands. So let's take those two examples here. And if we are creating a alias for the remove command rm, we can set it up by adding the -i option. So once the alias is created, every time we run the rm command, now it's running that alias. That means uh, the -i option of the rm command is applied. So every time we are running rm command, the system will ask us ask whether we should delete those files. So give you a chance to double check whether you should really delete those files. And now in the second example, we can create alias uh, to uh, to a very long Linux command. So once the alias is created, we can just run the alias command, that alias uh, to get what we need. And in this example, we want to customize the listing of the Slurm partitions, and our sinfo command will have a special format as listing here. But if we are running that command every time we need to run a long command, uh, which is not desired. So instead, we can just create an alias called partitions. Then every time we want to run the sinfo command with that long format, we can just run the partitions alias instead. And if you are running the alias command alone, it can list all current alias in your user environment. And here the example is mine. So I'm running the alias command, and then it's showing all of my current aliases, which includes some short paths to my scratch space, and uh, some commands that can activate my mini forge, or some commands that can check my Slurm jobs status on expense. Okay, now any questions so far? And let me check the check.
Not at the
And
moment.
Okay, if no, then I'm keep moving to the next topic, which is about the command history. And the command history can list previously executed commands. You can also navigate your history with the up or down arrow keys. If you want to execute previous commands, there are also ways to do that. Now let's take a look at a few examples. So the first example is you can just run the history commands. It will print out a very long list in the result. If you have been using the system for a while, you, you probably have run a lot of commands already. So in this example, I just cut the output off and only show the last three executable commands from the history. And if you want to execute the large commands, you can do that. Uh, but I will show something. I would like to do that in the demo later. And since the history output is usually very long days after, you can choose only to list the recent executed commands by adding the number of commands you want to see. So in this example, we just list the last five executed commands. Uh, so the command will be history file. So then the history commands will only list the last five commands. And of course, the result can be directed to the stand-in of grep to list some particular commands you want. Like in this example, I want to get all of the history executable commands of the sinfo from the history output. So then I use the pipe we just learned, the pipe to uh, to get the standard output of the history and take it to the grep, and then the output will show all of my sinfo commands I run on the system. And you can also customize your command history. I would like you to consider a few customization methods. The first is you can configure uh, Bash to save its entire command history because the default record is 1000 in the Rocket Linux 9 on Expanse. Uh, you can change this by setting up two environment variables, which are the his file size and his size. Once you set them to the -1, that you can get you can ask the bash to save the entire command history. But if you have a cron or pipeline shells that generate lots of commands automatically, you probably should be careful to use this. The second customization is you can display and format a timestamp along with the commands in your bash history. You can set environment variables to customize that. And also you can append the commands to the history file rather than overwrite it. This is very useful when you are opening multiple terminals on the same systems. So those commands running in different terminals will not be overwritten once you set you have set appending the commands to the history files. And the last thing I would recommend is you can ignore lines consist of just one or two characters. So to save your space and make your history records look more helpful. So you can also set that in your with environment variable. And the next will be the navigating between the directories with the pushd and popd. And those two commands can help you navigating between the directories. Uh, these two commands are very useful for navigating between the directories, especially if you have more than two directories to navigate back and forth. The pushd commands can add directories to the stack, and while the popd commands can remove directory from that stack, and you can use the dirt command to list the current contents of the stack. And in this example, we have a directory called ppdem, and in that ppdem, we have two subdirectories, dir1 and dir2. Once we add the dir1 and dir2 to a stack with the pushd command, we can then navigating between those three directories, ppdem, dir1, and dir2 with the pushd command. And of course, if we want to remove any of them, we can run the popd command to remove those directories. We don't want them to stay in the stack. And here is a concrete example. When developing a application, we want to navigate between the code directories and the output directories. Sometimes we are not saving the output in the same directory as our code. So to navigate between those two, we can add those two directories to the stack with the pushd, and then we can run the pushd command to get back and forth to those two directories. And now I will have a very quick demo on expense, showing you how to navigate between two directories. But this time we can just, if you just have two directories to navigate back and forth, probably you can just run the cd dash command. This command will help you get to the last directory you cd to. Now in this demo, you see every time I run cd dash, I will go back and forth from the last two directories I'm working. So this can help you get to those directories faster. And another demo I want to show you is about the history. And I have customized my histories on Expense. So every time I'm running the history commands, my output will show me the timestamps of each command, so that can help me to get how to when I was running those commands, and to configure those histories, I can put those those environment variables I just introduced into my .bashrc file. So once I set it up, I can customize my histories every time I log in. So that's the thing I want to show you guys before I move to the next topic. And any questions so far? And let me see. Oh, okay, no questions. So then I'm moving to the next topic, which is about the environment variables. Oh,
We do have
I
a hand
see.
up. Mikkel?
Yeah, yes. Feel free to unmute and ask, or if you
Uh,
want type questions. Yeah, go ahead.
yeah. So about the push D and pop D. So basically, uh, every time I want to access a directory, I pop it, so I remove it from the stack, right?
Oh, no, you can the property is if for you to remove those directories you don't want from the stack. So once you have those directories to work in the stack, you always run the pushd command to navigate to those directories back and forth. So like in this example, we have three directories, the ppden, two
Uh-huh.
subdirectory, dir1 and dir2. Uh, Once we have all three into the stack, we always run the pushd commands to navigate between those directories.
Okay.
And once you're done your work and you no longer need those directories, then you run the popd command.
So what is the shortest way to CD? What is shortest command that allows me to CD to the top directory of the stack?
The top directory of the stack. Like
Yeah.
if you if your uh if your file structure is not that let me show you on in the terminal. So here if I'm in the in the door one, and here is my the absolute path of the of this door one. So if I want go to the PPDEN, of course we can just run the cd dot dot, and so then we get to the PPDEN. If we want to go to my say my scratch directory, which is it expands larger scratch my username, I can run the uh we can run the dot dot twice again. So then I'm going to my scratch directory. If say if we want to go to if the directories are in the home directory, we can just run cd, and then we will be back to the home directory.
Yeah, I
Uh,
understand how CD works, but your slide was about those two commands, right? Push and pop. And could you please demonstrate how do you typically like work with them, if if ever?
uh, sure. So now I'm in the uh let me check my time first. How about I demo this at the end of this training? So I can finish my topics first, and then
Sure,
I will share I will share you how to use the push D and the pop D.
sure. Thanks.
Okay. Okay, so now let's back to our topics about the environment variables. So Linux allows the use of variables like other programming languages. Uh, s- but it has some rules about how to create those variables. So, like the variable names must start with a letter or underscore. Numbers can be used anywhere else. Linux does not allow to use special characters in the variable names, and those variable names are case sensitive. There are two types of variables, which are the shell variable and the environment variable. The shell and the environment variables allow you to customize your environment and control how the applications behave on a Linux system. The shell variables are only known within the kernel shell, while the environment variables are known globally and are inherited by processes and shells that are launched by the kernel shell. So you will generally want to use the environment variables rather than the shell variables. Every shell variable is setting using the variable name equals to some value. If you have multiple values, you can use the column to connect those values together and save it in the same environment variables. And the space is not allowed around the equal sign, and by conversion, the variable name is capitalized. Shell variables are made into the environment variables using the export command. If you want to reference a variable, you can prepend the $sign to the name of the variables, like the $sign key. And here are a few examples about how to set the shell variables. We can save the variable t1 with with t1 equals to abcd, and the other variable t2 with the value efgh. And if we want to make the variable the variable to the environment variable, we run the export command, and we can directly create a variable environment variable with the export. And like in this example, it export t3 equals to ijkl. So when we want to get the value of those variables, we run the echo command, like the echo $t1, and also the echo double quote. Then the $t1 t2 can also get the values, and we can also put those that variable into the curly braces, and then you run the echo command. Still, we can get the value out. Once we launch a new shell in the current shell, only the environment variables can be displayed. So in this example, since t1 is not an environment variable, so in the new shell, we don't have the value saved in t1, but the t2 and the t3 have the values because they are environment variables. And shell and the environment variables can also be set with the declare command using the -x flag to export, and the -r flag to make the variable read-only. So that will be helpful if we just want to make some environment variable directly in the script. And you can run the env command to display all environment variables using the env command. And usually you will get a very long list on your screen, and including the variables you set all the environment variables from the system. And the configuration files is the next topic. Linux has a number of configuration files for customizing your environment. And to make things even more confusing, there's very special rules about how to run those scripts, and the scripts can include other or source other scripts, and some scripts only apply to the loading shells. But the good news is you can usually get by with just two general rules. Those two general rules are: the first, you can customize your environment variables in your .bash profile, and you can put your aliases and functions in the .bashrc file. There are interactive shells and a non-interactive shell, and the interactive shell is one that reads from and writes to the user's terminal. If you can end commands at the command line and see output, you are in interactive shell. But you also have an interactive loading shell, which is a part of the interactive shell that is launched using the SSH locally, or when the new shell is launched with the loading options. So this is where you will usually work. If you just like start a new shell with the bash command, for example, then you will get into an interactive non-loading shell. And if you're running some JavaScript in the batch model that usually you're getting in the non-interactive shell. So that's those non-interactive shell is not associated with a terminal. And there are some complicated order of execution, saying how those configure files are executed in the interactive logging shell and the interactive non-logging shell. And if you search how those shells shells and scripts are executed, the bad news is you will probably come across figures that looks like this. So it's too complicated for each types of shell and for each types of the scripts you're running. And the good news is you should only have access to your bash profile and bash rc on the system, as you are not the system admin. And you can, if you are opening your bash rc profile, you will find the content of your bash profile like this. In the first part, you will see some system default lines that you should not edit. And after that, you can put your environment variables in the your bash profile. And this is the same for the bash rc. And the first part is already set by the system, so please don't remove that. And then after that, you can run. You can set up your Linux environment, saying by adding some alias or load some modules of the system. Once you save in your this in your .bash rc, you will get you will get it executed at your loading time, and every time you have you start the interactive shell. And the next is about the pseudo file systems. The pseudo file system is comes from the philosophy that everything in Linux is a file. So Linux provides pseudo file systems that allow you to access dynamically generated content using the same tools that you use to access regular files. These are normally found in the /prod or the /sys directories. As a regular user, you will normally use this to get the hardware information. But you don't have to check the exact usually you don't have to check the exact content in the /prod, but you can Linux already provide you some commands for you to check the pseudo file systems, like the ls cpu command that can get the contents of the /prod CPU info and organize the results. So that's a good news for the users. Like in the output of the ls CPU command, you will find the architecture of the system and how many CPU cores are there in the on the node, and whether the system is hyper-threading or not, and many other useful CPU informations. And also the ls CPU commands can help you show which flag CPU instructions are supported, like the AVX instruction, AVX2 and AVX 512, which indicates the availabilities of instructions that can greatly improve the performance of some numerically intensive applications. So you can build your applications, compile your applications based on the information you get. And here is same for the memory information. So the memory information on the system is saved in the slash memory info. And this pseudo file system will help will allow you to know the total memory available on the system and what's the active memory currently have. Okay, next is the Linux cores. Linux has two types of cores. The single core preserves the literal values inside the code, and the double cores recognize the special meanings of dollar sign, like backslash, and some signs. And when trying to reference the variables, you can use the curly brackets to replace the double quotes. And like in this example, we have two environment variables, var1 and var2. If we want to echo those two environment variables with the single quotes, you will find that the dollar sign and the variable name will be printed out because they are included in the single quotes. If they are included in the double quotes, then the echo will return the value of var1 and var2. And in the last command, I just put the variables inside the curly brackets, and once the reference those variables, they can still get the we can still get the values of those variables. And if your strings don't require any special characters, you can use the single and double quotes interchangeably. This is handy if your strings have quotes. You can also use the backslash to escape the characters so that they don't have their special meaning. Like in the last example, if we want to, in the last line of this example, if we want to print the dollar sign and the var2, and with two backslashes before and after it, we can add more backslashes to escape some characters we want to print out. And here is the backquotes, and also called backticks. They are distinct from the single or double quotes and capture output of a command. Note that this is not the recommended way to capture command output. You should use the dollar sign and the round bracket instead. But we are explaining the backticks here, since you might see them in some scripts you inherit. So once you see those backquotes, you know that they are going to run some command and return. I mean, sometimes they will be returned or assigned the output to new variables. Okay, last is about the five permissions. In the Linux system, five permissions are designed because Linux is a multi-user environment. The access restriction of files to other users on the system is applied. We have read, write, execute as the five permission, and in Linux we also have the three types of user, which are the user, group, and the world. Each file in the Linux has the following attributes. There are owner permissions that can determine what actions the owner of the file can perform on a file. And the group permissions determine what actions a user who is a member of the group that a file belongs to can perform on a file. And there are other permissions indicate what action or other users can perform on a file. And if you run the ls command in the long listing format, as we introduced before, the first column of the output can tell the types of the file or directory or the link. Like if it's showing the D, it's that entry is a directory. It's a dash. If it's a dash, it will it's a file. Or if you find the L, then it's a link. Then in the next columns of the output, you will find the permissions for the owner, group, and others. The column 2 to 4 are the permissions for the owner, and we have the RWX. If that group doesn't have permissions, it will be shown as just a dot as a dash. So the column 5 to 7 are the permissions for the group, and column 8 to 10 are the permissions for the others. If you want to change the permission, you can run the chmod command to add or change the permissions, as long as you have the permission to make that change. And you can add the dash capital R to change the permissions recursively in a directory. And you can run the change mode command like that u change mode u plus rwx. That means give the owner read, write, and execute to that file. And if you want to remove the permissions, like here the O minus W, that means you want to remove the write permissions to others to that file. And you can also use the change command in the absolute model, which are the numbers, and those numbers have the related execute, write, and read permission. And you add those numbers up, then you get the how the exact permission change you want. Like if it's you gave the 777, that means you're adding the read, write, and execute permissions to all owner, group, and others to that file. And as a Linux user, you probably want to know why there execute permission on the directory, because the directory how can we execute a directory with the execute permissions? That's because the permission effects on file versus directory is different. So when we are talking about the RW and X on a file, we can easily understand it's about the read the file content, write to the file, and execute the file. But in the directory, if we have the R permission to a directory, that means we have the ls files. We can ls files under that directory. If we have the X direct permission on a directory, that means we are allowed to cd to that directory. So that's not execute some directory, but just allow you to get to that directory. So we usually if we want to cd to some directory, we want to list to get the permission to list all files. Then we probably want to add both R and X permissions to that directory at the same time. Okay, here is a summary about today's training. So today we have learned the intermediate Linux skills, and we hope that they can help you to become more effective users of advanced cyber infrastructures. This tutorial can provide you with the tools to customize your user environment, can help you automate tasks and construct simple workflows. So while we cover most of what you should know, there are many resources on a wide range of topics in case you need to go deeper. And here I list two websites that can help you learn more about the Linux if you wish. And I also have a few extra slides about the Linux from the AI. So if you need to help with Linux, you can consider to ask or your questions to the AI like the ChatGPT or Cloudy Code or and usually AI is very good at explaining the classic Linux commands, syntax, and options, and they can help you understand those commands better. But you should still learn the Linux first, so you will not be misguided by the AI's result. Like if you want to ask AI to help you with some Linux tasks, you should know what what do you need with the right questions, so AI can fully understand what do you want. Like in this example, I want AI to create a subdirectory called my file, and then under my file create a few different files with the file name in this XXYYZZ text, and I tell AI what the X is and the Y is and ZZZ is, and the AI can help me create those files once they get my idea. Next, you can just validate the answers through your test. You can check whether the results are right, but be very careful not to let AI to remove your files. And you'd better to have a backup. And we also have homework if you want to learn more. And I put the link to the homework at the bottom of this slide. And those homework can help you to review what we talked about today. And the last slides are not included in today's session, but we have those slides about the file systems and the hard links and symbolic links if you want to know more about those. And thank you so much. So that's my talk today. And any questions?